Hello. So in this video, I'll be showing you a simple example of Golang concurrency. Without further ado, let's get started. Okay, so in this video, we learn about Go concurrency from a simple example. So before starting with the concurrency part, we have certain boilerplate code. Let's read the code. So what we are doing right now is we have a start time of the code and we have the end time of the code, and at the end of the code, we're just printing the end time. Okay, and I'll simultaneously run the code. I'll do go run main.go. Yeah. So let's see what's happening inside the code. So we are iterating from I equals to 1 to 30, and we're calling this dummy API. This API is giving us a response and we're just printing out the response. So let me just show you the API. This is the API that we are using right now. So as you can see, if we put 1 over here, it will give us a response, something like iPhone 9, for example. If we give 2 over here, it will give a different example. So you get a gist of it. Now, at the end of this, we can see the code took us 17 seconds to execute. Now, what our goal is, we'll use concurrency to fasten this code. So we have this file called concurrent.go, and we'll just firstly do one thing is we'll copy our main.go's code over here. So let's copy over this. And now let us think how we'll like use concurrency on this code. So as you can see that the code inside the for loop is the one which is taking a lot of time because of the API call. So what we'll be doing is we'll putting this code into a function, and we'll be calling it using Go routines. Okay. So let us write the function. We'll name the function as API call. So we'll do func API call. For now, let us only pass an integer to this function, and if we require new parameters, we'll look at it as a num. Okay. So I'll copy this code over here and I'll just paste it over here. Okay. Now what I'll do is I'll just call the API call and we'll pass in I over here. So now to make this a Go routine, we'll just add the keyword Go. What we want now is there's one thing missing in this code. So the usage of wait group is required. So we'll add a variable called var wg, which will be nothing but a wait group. It will be sync dot wait group. Okay. So now let me explain why we're using the wait group. So for an example, our code was I is equals to 1 to 3. So we called go API call 1, go API call 2, go API call 3. So when these three calls are made, the API will take time to give response to us. So the function will be executing. But after we come out of this for loop, our Go code does not know that the routines are being executed, and it will just print the end time and end the code without these responses even coming to us. So we want our code to know that, boss, we have to wait for the Go routines to finish. For that case, wait groups will help us. So what we'll do over here is whenever we call our Go routines, we'll add one to our wait group. So now when we go to our API call, what we'll do is we'll do differ wait group dot done. You can consider this as subtracting one from the wait group, and then after the end of our for loop, we'll we'll add wait group dot done. So what this will do is wait group dot wait. So what this will do is it will wait until the wait group again turns to 0, and only after that it will execute the code below it. Now I think that is enough. Let me just check the code. So I think now we can run our code and we can see the difference between a normal code and a Golang concrete code. So we'll go to different partial and we'll just run go run concrete.code. Let's see. Is the reason it is hanging now? Let me just cancel it out and rerun it. Go run concurrent.go. Yeah, so it worked. So as you can see, our previous code took 17 seconds and this code just took 1.7 seconds. Mind me that this 1.7 seconds is just because of the slowness of the API call which we are making. But even then, it is a good way to fasten our code. Now what we'll do is there are some cases that we have to take the response from the API and store it somewhere. So for that, we'll be using channel buffers. Okay, so now we'll create a channel buffer. So the syntax is simply we just create q is equals to make chan string, and now we have to pass a number. The number should be greater than the number of elements we are adding in the queue. So in our case, as we are adding 30, I know we are adding 30. That's why I'm adding a number as 40. In actual cases, you have to add a very big number so that when you add elements to the queue should not be full, which will give you an error. So after this, now what we'll do, we have to pass the value to our queue. So for that, we'll pass our queue to our API call function. So we're passing it over here. Now what we need to do is go to our API call and we need to receive this parameter. So what we'll do is we'll just add c chan string. Sorry, c chan string. Yep. So this will be fine. Now we'll not be printing it inside our function. Rather, we'll just take the response and we'll print it outside our function. So this code I'll comment out. And here, what we'll be doing is we'll be taking the response inside the channel. So we'll write string of our body. Okay. Now, after we have done this, when we go to our code, as these go routines finish after wait loop dot wait, we'll just close our queue. After closing our queue, we'll iterate to its elements and we'll just print them. So I think our code is perfect now. Let us test it. We'll clear it out and let's see. So as you can see, this code just took 870 milliseconds. And as you saw, there was a wait when we ran the code. It was because the go routines were being finished and the data was being stored in the buffered queue. So that's all for this video. Thank you.